I'm going to briefly explain Nikola Tesla's idea for keeping a wireless thumb on ships at sea. It's an idea of his that sets up a global resonant grid that can be utilized for measuring any ship's location anywhere. Have the Earth, and you're going to put a transmitter on top and a transmitter at the equator. You may want to have another transmitter polar opposite, but it might not entirely be necessary. If this transmitter sends out wave pulses going around the world this way to be reconverged at the bottom here, and then they continue going past around, they go back. If the wave frequency or wavelength is resonant to the polar circumference of the Earth, it will set up standing waves across the whole globe going north to south. Then if you have a pyramid on the equator, similarly sends waves this way, they continue around the Earth that way and come back, it'll set up a longitude and latitude grid of standing waves going this way and standing waves going this way. Because the polar circumference is smaller than the equatorial circumference, the polar circumference equals the equatorial circumference equals the grid that comes across here. Any ship, water blue, some creativeness going here. I don't know what the heck that was, but that's the sail. That's me on there, who doesn't know how to sail. Let's say we have a Tesla coil on the ship. If we put a small Tesla coil on the ship that's connected into the water anywhere on the Earth, let's say longitude and latitude, whatever this coil up here is tuned to, the plate capacitor here, L1, L2, C2, C1. The specific chosen L2, C2 will determine what frequencies this coil resonates at and what will allow signals to go up, just like an acoustic Helmholtz resonator does. Because of the inductance and the specific capacitance, certain frequencies will resonate with it and have easy passage up into the collector. Fill up with charges around the top. No, that one doesn't work. Yeah, fill up with charges at the top and then go back down and then come back up. So the charges will oscillate up and down in the Tesla coil on the ship, and depending on where you're at on the Earth, you will have a different amplitude or wave packet, or depending on the characteristics of these chosen waves, this coil will resonate to the combination of the two waves in a very specific way to wherever it is on the planet. Additionally, different wave packets can be sent out such that you can encode information in there so that wherever you're at, the way that wave packet's either expanded or contracted, depending on where it is in amplitude around the Earth, you can determine your location on the Earth anywhere by correlating this coil. I'm oversimplifying it right now to make it clear and understandable, but there's a little more complicated equations to solving this and making it so that you can actually use it. Another way is to have multiple coils on the ship spread a specific distance apart, and the signal's resonant to this one versus this one. The amplitude of this gives you different positions for everywhere or at different places around on the ship. This was to do this all electrically. However, what I find the most interesting is, just like there is a capacity for electrical alternating currents conducted through the conductive Earth to be stepped up to, you take the low voltage, high current, step it up to high voltage, low current in electronics, the exact same thing can be done with a mechanical analog of the magnifying transmitter, as I'll show up here. So what it does is it takes long stroke pulses, which are equivalent to high current, but low force or low pressure, so low voltage, to very short stroke, which is low current, but very high pressure force, but of the same frequency. Equivalent to how a Tesla coil works, where it steps up the voltage, reduces the current, you can step up an acoustic wave by reducing the stroke length and increasing the force or pressure behind that same stroke length, though. So it's the same power output, but a different characteristic of the wave. Why this is important is power loss for electronics is resistance times the current squared. So when you reduce the current and step up the voltage, your power loss drops proportionally. Let's say we step up the voltage by 1,000, the current will drop by 1/1000th. The power loss will be 1/1,000,000th. 1/1,000,000th of what it would have been for the same power out. If you step up the voltage by 1,000, reduce the current by 1,000, your power loss will drop by 1/1,000,000th for the same power output. So what that means is, if your power loss is dramatically dropped, that means the voltage power loss over any distance across the Earth basically goes to zero. As well as the conductive area becomes so large, resistance of any conductor is equal to rho times the length of the distance of conduction divided by the area of conduction. What you want is a high conductive input place for the transmitter, because obviously at the point of transmission it is got the smallest conductive area. But once you get the currents into the planet, and if you do it at a high conductive area, and honestly anywhere with salt water would be a high conductive area, even though rho of the dirt in the earth is, let's just say 10 to the 6th, the length transmitted across any distance across the earth, 2 pi r for the circumference of a circle. The radius of the earth is on the order of 10 to the 6th. So L equals 2 pi r times approximately 10 to the 6th. And then if this is still being divided by the area of conduction, where we get pi r squared, approximately 10 to the 12th, because the radius is getting squared here. Put this under here, the 10 to the 6th, 10 to the 12th, and 10 to the 12th will cancel out, and you end up getting the resistance is being lit in single or double digits, just astronomically small relative to even using a thin conductive wire. So when you combine the fact of increasing the voltage to reduce the power, the current to get a dramatically lower power loss, so the current drops this to 1/1,000,000th of what it would be for any normal conductor, and then the resistance becomes single digits or double digits. This could be triple digits and it wouldn't matter. This goes dang near to zero. Current goes dang near to zero. What Tesla wanted to do at 100 million volts, since power equals volts times current, at 100 million volts, we only need 1 amp. And the power transmitted is equal to 1 million watts, or 1,000 kilowatts, or 1 megawatt. For a 1 megawatt transmission, when power loss is in the single digits of watts, power loss could be 1,000 watts, and it still wouldn't be 1% of the power across the whole Earth. I'm sorry, that would be to go around the whole Earth even. We only have 1,000 watts lost for a 1 megawatt transmission around the whole Earth. Now that equivalently applies to when you do the acoustic or mechanical analog of the step-up transformer, where you take the mechanical oscillations, step them up. They have the same transmission power loss. Power loss in mechanical oscillations and acoustics has to do with motion dependent, because just like in electric currents create ohmic heating, high stroke length or vibration, the distance of particle travel for any, the more the particles vibrate or move back and forth, the more frictional losses or frictional heating you get. So by stepping up the acoustic waves, just like you would step up the electric currents, you get the exact same analogous power loss reduction for transmitting acoustic waves through the earth. So if you've seen my video about how the pyramids are used for either damping out waves in the ground, or it could be used as harmonic resonators for putting vibrations into the earth, what this would functionally look like is at one of the poles, at either the north, or I'm going to switch around here, I'm going to go to where everyone else is talking about. Let's say what this would functionally look like is at the South Pole in Antarctica, you would have a big pyramid that would in some form resonate to put out acoustic waves into the ground in stepped up fashion, would produce waves that go perfectly parallel to the equator, and it would create a standing wave this way. And what you would want is a pyramid at the equator to then put out the same acoustic waves going around the earth. This could also have a more complex grid where you have, instead of right at the equator, you do one at the South Pole, and you do one at, say, 30 degrees, and you do another one over here at 30 degrees. So you have, it will give a more complex interference pattern for anywhere on the earth to get a much more easily registerable signal for your location, the time, all the things Tesla mentions that can be used for the digital or the electrical version can be done analogously with acoustic waves through the ground or in water. And especially through water, because acoustic waves travel much, much further through the water, like way further. And if you talk about even going to the SOFAR channel down at the bottom of the ocean, what happens so this is the sea floor, this is the ocean top, there's a point where the salinity changes of the water and the pressure changes, where you get what's called the SOFAR channel, where acoustic waves produced, let's say you have your pyramid here, it produces acoustic waves. Those acoustic waves will go to here, and they'll want to deflect back up. And as they do try to deflect back up, they will get bounced off of this thermocline. And all the acoustic waves put in will get trapped in this thin layer of the ocean. And in fact, this is how whales communicate with each other around the world, as they will dive deep enough to a point where then when they output their acoustic sounds, their voices or their songs will get trapped in the waveguide channel that is the sound, I think it's sound sonar fixing and ranging. I can't remember what it is off the top of my head, but why this is important, why this makes it so it can go around the entire world, is if you think about an acoustic wave, if you have it in free space in the air, and this is one of the reasons why it's said that Tesla's wireless transmission system can't work with electromagnetic waves, because the spherical dispersion you end up getting, let's say you have the energy in a pulse, you get a spherical expansion of the energy. So if you have a pulse, the energy that's in each wave pulse is contained in the surface of the expanding wave. So as the wave expands and gets further from the point source, the energy surface area equals 4 times the area of the circle, which equals 4 times pi r squared. So as the radius increases, this surface area, you have, let's say you have 1,000 joules. You have 1,000 joules contained in the surface of any expanding sphere. So the intensity or the energy density anywhere on the surface of this sphere, as it expands, the energy density per square meter gets smaller and smaller and smaller. But as the radius increases, that surface area gets so large so fast because the radius is squared in this surface area, because you're getting 1,000 joules divided by 4 pi r squared. So as radius increases, the energy density anywhere on this sphere, expanding sphere, dramatically reduces at a rate of r squared. So if this is just in free space, or like, let's say this is a sun or a star, the energy being able to collect for solar energy would be reducing dramatically as you get out going further and further. However, what happens when you get this SOFAR channel is that the wave from your point source, well, you have your point source here, and the wave that expands from it, this portion of the wave isn't allowed to expand outwards. This is known as cylindrical expansion versus the spherical. The first example is a spherical dispersion. This is cylindrical dispersion. And what ends up happening is the energy, this is the height of the SOFAR. So in this example, because all the energy that would bounce up or down gets reflected back in to this thickness of the cylinder, the energy density equals, let's say we do the same 1,000 joules. That 1,000 joules gets expanded, diluted, if you will, or the energy is contained within the surface area of the cylinder here. Surface area of that is the height times becomes the surface area of this, which becomes 2 pi r. This goes to 2 pi times the height times the radius. As the radius increases, the energy is contained along the surface area of this. So as the energy density at any one point of this expanding cylinder, and once you get to the size of going around the whole Earth, this height is basically so small and insignificant compared to the rest of this, it doesn't really make much difference. It becomes like a thin shell relative to the Earth. The thicker this cylinder, less is contained along the edge of this surface area. But as the radius increases, is what we saw before. If we had, for the cylindrical version, for spherical, what happens is the acoustic, or the energy in the wave being trapped in cylindrical expansion versus spherical expansion, the energy available at any one point, some square meter by meter on here, versus the energy density on any one square meter of this surface area versus any one square meter of this surface area at the same radius will be r times higher at any radius away. So what that means is, at a distance 1 radius of the Earth away, the power or the energy available in the surface of this expanding wave is the radius of our Earth times larger. So you get a 10 to the 6th. So just like when you step up the voltage to reduce the current, you get the 1/1,000,000th, or you get the proportional decrease in power loss, you get a similar proportional decrease in power loss by trapping the wave in cylindrical wave expansion in the SOFAR waveguide channel. So even if we can't get the mechanical waves to go around the Earth and just normal at the surface of the Earth, even through the water or even through the mechanical waves, at the SOFAR channel, we know this is a thing because whales can use this method to communicate with each other around the world. Their songs can travel around the whole world when they go down deep enough. I'm going to try and draw a whale here. That's just a fish, isn't it? When they do their songs and they get trapped in these waveguide channels, the energy density anywhere around this expanding sphere or expanding cylinder is R times larger than it would be if they did it in free space up here. We already do know sound travels much, much, much further in water to begin with, let alone once you get it trapped in the waveguide channel, it goes around the whole world. And this is coincidentally how they can find down pilots or submarines. This was very, very coveted information during the time of Tesla for submarine warfare. That's how you stay hidden. If any noise you make as a submarine at this level goes much, much further too. And by putting hydrophones around, they can pick up the sound anywhere. Coincidentally, there's also waves that bounce off the ocean floor too. Even if we can't get the waves to go all the way around the Earth, at the surface of the Earth, if we get the waves to go into resonance around the Earth at the bottom of the ocean, or even just setting up specific resonators in each ocean so that each ocean has a specific sound resonance to it that you set it up, and coincidentally one of the shapes of a thing is called a sound. I wonder why. It's just a coincidence. If we have, what was I going to say now? There's the ocean floor. Sorry, Free Willy. In our previous example, we had a ship that had a Tesla coil on it that went into the water, and it could pick up the electrical oscillations. And I had said that you had to tune this specific electric resonator, the Tesla coil. Tuning you find where you pick up the amplitude the highest, that gives you your signal that where you're located. So you would do you'd pan across your frequency domain to find where it hits, and you see where the amplitude increases. Instead of having specific mechanical analogs of the Tesla coil, what you just need is a mechanical oscillator, or a tuned mechanical oscillator, i.e. either just a set of tuning forks, or what do we normally have on ships already? Ship bells. The acoustic version of this, so a person on the ship would then hang a rope off, drop a bell into the water. Or you drop a set of bells, each different size. Each different bell will resonate to any waves that are into the water. Cool part about it is it, one, I don't even think it needs to go all the way down to the SOFAR channel. But if you had to, you just drop your bell on a line to go to the bottom of the ocean. And honestly, it really doesn't matter how much power you can have left in this acoustic wave going through the water around the Earth in resonance. If it's resonant to any one of the bells, it'll just slowly keep building up and building up and building up and building up until the bell is vibrating with it. It's just like the two tuning forks together. Exact same thing will happen. Let's say one other bell, it just so happens to be the red bell. Let's say the waves that are going through the Earth, these will start resonating with this bell until it starts vibrating. And all anyone on the ship has to do is, cup on the ear with the string on the bottom of the down to the ocean, and you just listen to which bell is resonant. And which bell ever is resonant, you can know based off the frequency of the waveform that's created from the interference of the different waves that are going into the Earth. The beat frequency of these two waves interfering will resonate with one of these bells. And which bell resonates will tell you where you're located. I hope that makes sense. So, and I find it very interesting. There's so much lore behind the actual bells to ships and the ringing of them. I was even reading some legend that sailors believe that the soul of the ship is in its bell. And even when a ship goes down, you can still hear the bell, the soul of the ship resonating deep in the ocean. And echoes of the ship's soul can be found. Now, coincidentally, if you have a copy bell of every ship in your navy, make 2 bells for every ship. One goes on the ship, one stays at home. If you ever have a ship go down, you want to find the wreckage, bring the same bell, the bell that's tuned to the same bell that's the ship's bell. Go out into the ocean somewhere, and you just ring your bell until it starts resonating the other ship's bell. And once the other ship's bell is, you stop your bell, you can listen in for the other bell. Let's say down ship here, and it had its ship's bell. This ship's bell down here, let's say you know this bell, this one matches this bell, this is the same as that one. So you just do a clapper on this, you get this one vibrating, it will start this one resonating. Once you stop this one, this bell will keep resonating. And if you have multiple ships at the surface, wherever you hear this bell's signal coming from, you can triangulate the location of that downed ship at the bottom of the ocean. I mean, similarly, if the ship had a tuned Tesla coil, you could do the same thing if that was still insulated or in a box. Isn't that kind of cool? So technically, the soul of the ship is still, you can find it because its soul is still resonating. If you got the right bell to get it to resonate, you can cause that to resonate, and you can cause it to then emit a sound that once you stop this one, you can find it through triangulating its position from the surface. Just like what's done for downed pilots is they'll drop a percussion mine to the bottom, and then the percussion mine will explode, sending out waves. And we have hydrophones sitting all over the place now anyway, so they just listen for this stuff all the time. That percussion wave will tell you generally about where the airplane went down over the ocean. Pyramids, bells, ancient navigational techniques that if these pyramids stopped working, we would no longer be able to navigate the oceans using just the bells. You would have to use the stars. You'd have to then have star maps and everything. And if we lost this technology and the pyramids were all defunct, and it doesn't have to be pyramids, you could get people at each of these places to just constantly putting the ground vibrations in by doing dances. Daily rotation of people doing prayers, vibrating the ground. Due to the seismoelectric or electroseismic effect of the Earth, mechanical vibrations put into the earth in the desert will specifically travel further, not just because of the mechanical vibrations through the earth, but because of the piezoelectric effect of quartz and sand. The mechanical vibration, some parts of it will rectify into a electrical waveform further and faster. Which means let's say you're out in the desert in dune land. Every step you take will send wave pulses out from where you walk. Just like in the movie Dune, where they talk about how you have to go out, they have to do the weird step so that the sandworms that come and eat you alive don't just come and eat you alive. You have this system of sending mechanical vibrations through the ground, and we do a phased array setup where you don't have to have any giant wave, you just have to have small waves all over the place and get them coordinated, and you do just like a phased array directed energy weapon. If you're out in the desert and you're walking at pace, you can be triangulated anywhere in the desert, and anyone who's got good enough phased array acoustic technology can send a ground wave to sandbar.